Hello, good morning, and welcome to Homework Helper for section 1.1. Now remember, this is the second unit or the second course of the curriculum I'm using. It's all kind of jumbled together. We skipped some chapters from the last one so that we could include these ones because we really want to make sure that we hit quadratic functions before you guys go off to geometry. So that's exactly what we're doing here. The first section on our homework is the distributive property. And pretty much the distributive property tells us, in this case, this is the distributive property of multiplication. And so pretty much what that means is if I have an A and that's being multiplied into a parentheses where I have a B plus a C, that's going to be the same as A times that B plus A times that C. That's the general form. Now, a lot of people have some creative ways of trying to remember how this works. One of the most common ways is just to kind of think of the A goes to each term like that. And the terms themselves are broken up by that addition sign. That's how we know we have these different terms. So when I look at number 1 here, I have 3 times the quantity 2x plus 7. And so using that idea of the arrows, it goes like this and it goes like this. Or using my original formula, we could think of it as 3 times 2x plus 3 times 7, which when we simplify it, 3 times 2x is 6x's, and 3 times 7 is 21. So that would give us our answer there. Now these will get a little bit more complicated when we start looking at our fractional multiplication here. So let's look at number 7 here. This is the most complicated here, where we have a negative 4x over 11 times these things. So I'm going to do the exact same thing I did in number 1, right? I'm going to view it as this times this, and then this times this. So that will give me a negative 4x over 11 times 121x, and then that's going to be plus a negative 4x over 11 times a 22. Now when I do this, here I'm actually going to zoom in here. When I do this, I'm viewing this, I can view this as 2 fractions, right? So this is all over 1. And so when this happens, I can reduce my fractions because I see 11 and I see 121. And 11 is one of those tricky numbers where it's tough to know what goes into it. But I'm pretty sure 11, whoops, let's not do that. I'm pretty sure 11 goes into 121, and in fact it does 11 times, okay? So that tells me that when I look here, 11, 121, it's the same as 121 divided by 11, so this reduces down to 1, and this becomes 11, okay? Likewise, when I look over here, I've got to close my calculator so you can see it. When I look over here, this 22, clearly 11 goes into 22 twice. So this becomes 1 and this becomes 2. So what I have here is on my left term, I have a negative 4 times 11, or negative 4x times 11x. So I have a negative 4x times 11x. And here I'm adding a negative 4x times 2. So now I can simplify this. This negative 4 and 11 becomes negative 44. X times x is x squared. And then negative 4 times 2 is negative 8, so minus 8x. So this becomes my answer. Okay? So don't be scared of fractions. Don't try to put it in decimals. It's going to be worse for you than if you just work with the fractions and work at how they behave. So that's the first section. The next section is we'll be talking about recognizing linear, exponential, and quadratic functions. And just to remind everybody of what's going on. So when we have a linear function, that means each step we add the same number. You know, this is the common difference. Okay? When we have exponential, this means each step we multiply the same. This is the common ratio. And then a new type would be quadratics. And quadratics aren't going to behave in that same way. So we're going to have to kind of look at quadratics to see how they behave. So let's go ahead and begin here. When we start, we see that our x's are going up by 1 each step. And now we need to figure out whether we're adding the same number, multiplying the same number, or if something else is happening. So when I look for 64 to 128, I know that if this were a common difference, it would be plus 64. If it were a common ratio, it would be times 2. So let's look at the next one. 128 plus 64 is not going to be 256. Times 2 is going to be 256, okay. And then times 2 is 512, yes. Times 2 is great. So I've realized I have a common ratio, which means I have an exponential function. So the typing characteristics, this is exponential. Exponential. The explicit equation is going to take me a second. So I know that my base form of an exponential geometric is going to be f of x equals my n sub 0 times my common ratio to the x power. Okay, so I'd have to work backwards to figure out what my n sub 0 was to get this. So let's do that. So if I have 6, half of 6 is 32. That's 5. 4, half of 32 is 16. 3 is 8. 2 is 4. 1 is 2. And then 0 is 1. Hey, how neat is that? So that means my n sub 0 is 1. So my explicit equation is f of x equals 1. Don't need to write 1. It's just 2 to the x power, and I'm done. And the recursive equation means we look at the step before. So that means f of x is f of x minus 1. So f of 8 is f of 7. What do we do to make 7 into 8? We multiply it by 2. So we're done there. So you're going to need to know a bit of that, and then just be mindful when we find the one that isn't what it appears to be. Okay. Next is identifying rates of change. So rates of change is the same thing as slope. So we just need to be able to find places where it crosses perfectly. I see that it crosses here perfectly. I see that it crosses here perfectly. What is this, a half? What is this? Oh. See, this is 1. Okay, so I don't care about that. I care about this one. That one's way easier to work with. And I see that I rise 4, and then I run 1. So my slope, which is the same as rise over run, which is the same as the change in y over the change in x. I see that I rised 4, ran 1, so my slope is 4. And that's it. For this, change in x, change in y. And I mean, and if you need to, you can use the slope formula. For example, in number 16. Being able to figure out the slope here, it's probably best to use the slope formula, which is y2 minus y1 all over x2 minus x1, where x2, y2 means the coordinate points of our first, and x1, y1 means the coordinate points of our first here. So y2 would be negative 16 minus y1, which would be 12. x2 would be negative 11. x1 would be a negative 3. So when I subtract a negative number, it becomes plus. We then just simplify this. This becomes a negative 28. This becomes a negative, what is that, 8? And you can reduce that down from there. And that's it. That's how we do it. Slope formula, probably pretty good to know if you're not already comfortable with slopes. It's an easy way to find it when we're given 2 points. Slope triangles are easy when we're given a line. But slope formula is also useful when we have a table. Here's our x, here's our y. So I do 68 minus 65, y2, y1, 26 minus 25. Okay, and that gives me what? 3. There you go. So make sure you're doing all this. Do your homework. Be prepared. Some of it's challenging. Some of it's not terribly challenging. A lot of it's kind of a review. just to get our brains thinking so that we're ready to tackle these quadratics. All right, have a good one.